We're going to talk in a little bit greater detail about the software development lifecycle. We've talked about it in database. We've talked a little bit about it in web programming and C# and Java programming for that matter. But I want to kind of stick it all together and give it a broad overview of the software development lifecycle and the different things that are involved in it. So you'll see slightly different names: application lifecycle, software development lifecycle, web development lifecycle. You'll see a lot of different terms, but they're always talking about the idea of starting a project at the beginning and getting it to the end somehow. All right. And the other thing you should know is that there's different versions of this, but they're all very similar in a lot of ways. So this model that we're looking at right here has requirements, design, development, testing, and maintenance. It's got 5 stages. But we're going to look at, I think in the next slide or two, we'll see another model that actually has it as 6 stages. Well, those different models aren't really missing anything. It really comes down to whether we combine certain things into one level and give it a name, or whether we split it up into 2 separate levels. But basically, it revolves around this activities that we do to create a new software project from the time we start it to when the project matures, meaning when it's done, if it's ever done, right? We'll talk about that too. All right. So we're going to look specifically in this video at the waterfall model. Okay, and the waterfall model, it's the one everybody teaches. It's in your books. We've talked about it in almost every resource we've used. We've talked about the waterfall model, but it's kind of considered old school. So back in the day, you used to go to the store, right? And you'd pick up your CD-ROM, or if you're really old, you picked up your big pack of discs that had your application on it, whether it was AutoCAD or Microsoft Office. You'd buy it at the store and you'd bring it home and you'd install it on your computer. And that's the application you would use until the next time you went out and bought the new version of that software. Okay. So we didn't have the internet. So since we didn't have the internet, you couldn't get an update or a fix very easily. Basically, the company would have to send you a disk or something with the software to update if you needed a problem fixed. And so it was really, really important that when software went out, it worked as perfectly as we could make it. And as software packages grew, that got harder and harder and harder as we got more and more features into those products like Microsoft Office. It's almost impossible to ship a product like that without some bugs in it. So the waterfall model was very important at one time. And basically what the waterfall model said is that we went through these stages when we developed an application, where we gathered the requirements for the application. What does it need to do? What are every feature that this product needs to have? We need to define it right now. And then once we know exactly what we want it to do and all the features we want it to have, then we're going to spend some time and we're going to design those features and we're going to make it perfect. This is what it's going to have. This is how it's going to work. Once the design is done, we'll go in the development phase. That's when we actually write our code. Once our code is written, we'll test it all and make sure it's perfect and everything works. And if we might have to go back here and do a little bit more development if there's a bug, but we get it fully tested. And once it's fully tested, then we can send it to manufacturing to make that disk that we're going to package up in its nice little cellophane wrapper and send it out to the store. And then if people have some problems, we might need to do a little maintenance on it at some point. But we went through this process from start to finish. Basically, the theory was one time. Okay, so let's talk in detail about these different levels of the waterfall model. So the first level, requirements analysis. It's the process of determining the detailed business requirements for a new software system. So we talked about that quite a bit in database design, how we go talk to all the stakeholders, right? We go out, talk to all the stakeholders. We're writing an application for a bank. We need to talk to the tellers. We need to talk to the president. We need to people that talk about people that manage the software on a day-to-day basis. All the people that work at the bank, not just the president and not just the teller. Everybody that works there has to have an input so that we have a full picture of the requirements for the product we're getting ready to make. Okay, so who did that? Who does that? A business analyst is responsible for analyzing business needs and converting them into the requirements that can be executed by the development team. So there's specialized people who specialize, and they're often programmers, but sometimes not full-blown programmers. They don't need to be. What they really need to be good at is listening. They need to listen to people and determine those needs and be able to transform the written or verbal needs that are expressed to them into some kind of technical requirements that the developers will understand, right? Okay. So we spend a lot of time getting the needs of the business. We did that. We talked about a lot in database design. Getting those requirements, writing down those user stories to determine what each person throughout the business might need this application to do. Okay. The next step is the design phase. That's when we create plans and models and architecture on how our software is going to work. I'm going to take you right back to ERDs. This is the ERD portion, entity relationship design, that we did in our software projects. In our database projects, we talked quite a bit about this design and making sure our design represents the final product. We can use that design to go back to the stakeholders and say, hey, is this really what you think it looks like? You told us this. Does this design seem to fit what you think you need? Because once we program this, it's hard to go back and adjust it in this model. Okay. So maybe an architect of some kind, a user experience designer, those are the people that happen here. We're going to get a little bit more into the participants and things, and we're going to take this across different kinds of applications too. So we'll see that coming up. Okay. The next stage is the development stage. This involves actually implementing the design. We turn those ERDs into tables, and we create the code. We actually create the database project. We create the tables in the database. We create our stored procedures, all the things that we need. We write our programs. This is the part that we normally think of, especially for new programmers. This is the part you think that here's my job. I'm going to write code, right? So probably one of the biggest challenges we have in teaching programming is making programmers realize that this stage, the requirements and the design are important. And if you don't do those properly, you might develop a product of some kind. You might write a bunch of code that doesn't actually do what the people back in step one, the requirement stage, your product may not do what they actually wanted if you skip those stages. So who does this? Database administrators develop the database part. We might have programmers and developers that write the code that pulls the information from the database. There's technical writers involved. There's content developers. A lot of people work in the development stage. After we get it developed, there's testing. Okay, testing's used to assure that the final product does what it's supposed to do. If the final project is supposed to add two numbers together and multiply them by 7, we better get the two numbers added together and multiplied by 7 as our result, right? So we might have some test cases that we run against the code, which is what I do when I grade your homework, right? I say, this is what it should do, and then I'm going to put in some values and check it and see. And if you get the right result, you probably did okay. If you don't get the right result, maybe you didn't do okay. So the testing phase happens after the development phase. It identifies gaps between the system's expectations. Okay, I accidentally clicked there. The system's expectations, I talk about expectations with troubleshooting a lot, right? What do you expect to happen and what is supposed to happen? What do the requirements say are supposed to happen? If that's not happening, we need to debug it and compare where does our requirements not meet our expectations, or where do our expectations not meet the requirements, and figure out what's wrong with our software. Okay. So we use testers, and there are people, programmers, who that's what they do. They write the test cases. They write the software that tests the other software. And it's important to have that, because if we later go back and modify our software, if we have good test cases to run against it, we can run that code that automatically tests our software to make sure we didn't break anything when we did an update. Okay. The next phase after testing is, let's talk about different types of testing first, because this is important. Software testing, it's the process of varying software against its requirements. It can help to find defects, but it can't completely guarantee the absence of defects, meaning we try to anticipate all these test cases, right, that assume that the software works the way it's supposed to, but we might not think of everything. Okay. It's important to understand that testing saves us money. It's because it's way more cost effective to find defects earlier rather than later. Okay. If you go back to the old days, especially when we're shipping CDs out, we find a bug the day after all our CDs are manufactured and shipped out. It's hard to get all those updates out to the users. So really, this testing phase is really, really important, especially in this waterfall model. Testing methods. You might hear black box testing and white box testing. Okay, so what is black box testing? That's focusing solely on inputs and outputs. If I put in 7 and 3, it's going to take 7 plus 3 is 10, multiply it by 7 and get the answer 70. I don't care how it does it in the code. All I know is if I put this set of inputs in, I better get this set of inputs out. Okay. We don't really look in black box testing. We don't really care how the internal system workings happen, as long as we get the results. Okay. And black box testing will help us make sure that it meets all of the requirements that we laid out in that early step, the requirement stage. White box testing is a little different. That's kind of what I do when I grade your projects. They use their knowledge of the system internals when testing the system. So I'll pull up your code and I'll look at it, and usually before I ever run your code, I know what's going to cause your code to break. Hey, look, here that person's opening a file and they didn't use a try-catch block. So if I put a bad file name in there, their program's going to crash, right? So I'm using my knowledge of how the code works to test your system and find those bugs. Okay. And that's used to make sure that each method or function has a proper test cases available. So black box testing is when we test it not knowing how the things inside work. White box testing is when we use our knowledge of those to anticipate things that could break. And there's different levels of that. We can test each unit of code. Maybe we write some code that tests each class and make sure the methods of that class work exactly right. Just because the class works doesn't mean it plays well with others. Okay? So that comes in with integration testing. How do all those classes that we wrote here, and we tested each one of them separately, but how do they work when they all get thrown together? Do they work? Okay. Does the whole system ultimately work the way we expect it to? Okay. And regression testing comes back to that idea. We wrote a fix for a piece. Does it break all these other tests? Okay, so we want to make sure our new fixes don't break our old software. Right. So unit testing, integration testing, entire system testing, and then regression testing, it usually comes in when we're doing updates. Sorry about those little flashes there. Let's look at these phases. Here's our requirements phase, our design phase, our development phase. Sometimes that's called the implementation phase. Again, remember that these phases are often, sometimes they're combined in certain ways. So you might see models that only have 5 phases. You might see models that have 7 phases, but these 6 pretty much cover what they all do. It's just, so don't get hung up on the exact names. So the development phase is sometimes called the implementation phase. Okay? The release phase, you'll hear some people call it deployment. Some people call it the operation phase. The maintenance phase or the evaluation phase. Sometimes those terms get used interchangeably. Okay, so this chart I made several years ago helps people understand that these phases happen in every kind of programming we do. Okay, so in the requirements phase, we're always determining client needs. That might be the analysis phase for some people, or the pre-production phase, but we're doing the same thing no matter what you call it. We're trying to determine what our client needs, what our software has to have. Okay, design phase, we're planning the project. Development phase, we're coding and building the project. Okay, in the testing phase, we're doing black box testing and white box testing and unit integration, system and regression testing. In the release phase, that's where we're delivering the product or installing the product or running the product on the client servers or computers. And in the maintenance phase, we're doing support. We're making sure that our software keeps running. Right? So this is the names you might see for each of the phases, but this is what we're doing in each of those phases in this column. And these last 4 give you a little picture, or the next 3 give you a little picture of specifically web programming or database programming or just general programming, what we might call that, or what you might see at each of these phases. So web, I hear analysis a lot. Database, we hear about gathering requirements. So in database program, they might call it gathering requirements. In web programming, they might call it analysis. Again, different terms meaning the same thing. We're doing the same step, determining client needs. In web programming, at the design phase, we might see a wireframe. That's basically a sketch, right, done with some kind of software, or a mock-up of the website. Or we might be talking about client approval. Hey, this is what your website's going to look like. Okay. In the database phase, during the design phase, that's where we see the ERD and physical models. Okay. This is our planning for what our database is going to have in it. Okay. It's all part of the design phase. In programming, you might see a UML model that looks a lot like an ERD. Right? Here's how our classes are going to work together. Here's what each class is going to have. Here's the methods each class will have. Here's how the classes will work together. In the development phase, that's where we start seeing our code. That's where our code happens. That's the probably the idea you had as a programmer coming in. This is the part that you normally think of when you're being a coder. In web, that's where we'll be writing our HTML and our CSS and our JavaScript. If it's a web application, we're writing our PHP, or maybe if we're using active server pages, we're writing C#. That's the code that runs on the application server. In database, we're writing SQL or T-SQL. We're developing the applications and loading data for our database. In programming, that's where we're doing Java coding or C# coding or C++ coding or Visual Basic coding. It tells you how old the slide is because we don't talk about Visual Basic too much anymore. For web, the testing phase, you often hear the words prototype. Here's the prototype of our website. Right? We're only letting a few people look at it. Go in and make sure it does what you think it's supposed to do. Okay? In the database in the testing phase, we might be tuning it. hey, there's this query that runs and it works, but it's really slow, or it really puts a lot of pressure on the web server. Can we redefine that code in some way to make it a little bit more efficient, make it run faster for the users? In programming, we're doing testing. Okay. The release phase in web, we might call the release phase our launch. It's the launch of our website. Okay. In database, we're producing information for whoever's using it. In program and in just generic programming, we might call it the release phase, right? So the launch phase and the release phase, depending on whether you're doing web or traditional programming, or it might be called different things. Almost everybody, maintenance and support, used interchangeably for this phase. And then this last column over here, who's doing it? Requirements phase is done by an analyst or a business analyst. The design phase is done maybe by an architect or a user interface specialist. So UI is user interface, right? Our user experience designer. Who's doing the design? Game programming. We have people who design the game and think this is what it should look like and this is what it should play like. And that's hard to do. They're different than the programmers who might be down here in the development phase who actually write the code to make our software do those things. So the development phase involves developers, database administrators, DBAs, tech writers, content developers. Okay, testing phase involves testers. Release phase involves users. Okay, they're going to use it. And then the maintenance phase involves our support and our help desk. So this last column is who's responsible for these different things. So the software development lifecycle could have 5, could have 6, could have 7 different phases. These are very common terms and substitute terms, but we're doing the same things. In each different type of programming we're talking about, we might have different names and products and ways of referring to them, but it's still going through this planning process. This whole process is happening. Whether we're doing web, whether we're doing database, whether we're doing programming, it's happening. I told you Waterfall was old. Okay, so traditional Waterfall depends on a perfect understanding of the product requirements, and that's just not how the world works anymore. Okay, products aren't developed that way. You guys probably play games where you got the game in the stage and they've added features and added more characters over time and more levels over time. It's not a final product when it comes out. So traditional SDLC, you need to know about it and understand it because it's been modified in certain ways now so that we can do more modern ways of programming. And one we're going to talk about is called the Agile method, or Scrum is a version of Agile development, where we don't do these long projects that take 3 years to develop the next version of Microsoft Office. Instead, we get a project and we get it out the door fast, and we add features in short sprints. Okay, so they're often called sprints, and these iterations. This is what we kind of see our project doing. Let's get the first feature of our project done, maybe in 2 weeks, right? We're going to do requirements for a new feature, design and analysis for a new feature. We're going to test that little new feature. We're going to make sure it works, and then we're going to deploy it. And then we're going to start working on our next feature, and we're going to make sure that feature works and doesn't break our old feature, and then we're going to deploy it, and we're going to do these in short 2-week sprints. Get 2, 3, 4, 5 features, however many features. And I'm going to give you a different video that talks a little bit more about the Agile Scrum version because there's they got cool names for a lot of things. But remember, it's still based on this idea of get our requirements, design it, code it, and test it, and get it out to the users. But instead of doing the entire project as one big thing, we do it in these short bursts. And we add features as quickly as we can. There's advantages to this. Like if the client decides they want to change how a certain feature works, it's a whole lot easier to do it when you can do it in a short 2-week burst and modify something. We don't get so upset about changes in Agile development. So that's the end of this slideshow. I'll have another video that gets a little bit more detailed on Agile methods. Scrum in particular, if I remember correctly, the video I'm going to use. I'm going to use a video from somebody else on this because they do a great job on it and they know more about it than I do.